To work out the space complexity of the binary recursion tree, we need to calculate two values: how many levels the tree has, and at each level, how many elements being stored. So we'll start with the latter, as this is much more intuitive. Amy and Tiv have their data structure storing pre-computed maximum values of each subarray generated through the binary recursion applied to an initial array of n elements. The first level, the data is split in 2. At the second level, it's split in 4. The third, it's split in 8, and so on until each subarray contains only one element in each of the n subarrays. As shown by this simple example, no matter how many subarrays the level contains, the value stored, the number of elements stored, remains at n elements. So again, back to our general case, the number of elements stored at each level is n elements. So that's the easy half of the space complexity calculation. Now we must work out how many levels the recursion tree will have. So again, looking at the way each array is split in 2, we can see that the number of subarrays per level is always some power of 2, with the power increasing by 1 at each lower level. The lowest level, of course, has n subarrays, each with only one element. And from the problem definition as shown here in the top right, n is being defined as being 2 to the power of some integer k. So now just by looking at this pattern here, in the number of sub-arrays per level, we can see that there will be k levels. So counting down the levels, 1, 2, 3, all the way to k. So this will be the kth level. So now we can just use some basic knowledge of logarithms, since there are k levels, and we know that n is equal to 2 to the k. Therefore, k is equal to the log of n. So therefore, we now know that the number of levels is equal to the log of n. So now we're all done. We have the number of elements per level and the number of levels. So now we just need to multiply these, and we have our space complexity. N elements times the log of n levels, and therefore our space complexity is n log n.